Hey everyone, and welcome to another Deep Dive.
Yeah, welcome back.
Today we are tackling ratios and proportions.
That's right.
You know that thing you learned about in school with all the colons and fractions and stuff?
Yeah, it can seem a little dry.
It can be a little dry, but we've got excerpts from a math textbook.
Yeah, we are going to bring this stuff to life.
We are going to totally break it down and uncover all the cool stuff that's in here.
Yeah, we're going to show you how much it impacts your life every single day.
Exactly.
This is one of those areas of math that I think is so practical.
Yeah, for sure.
Like, we're talking art, we're talking aesthetics, we're talking, are you getting your fair share when you go out with your friends to get a meal and you're splitting a bill?
Oh, yeah.
Like, this is really, really useful stuff.
That's such a good point. I mean, who hasn't been in that situation where you're trying to figure out the tip and whose dish was how much? And
Yeah, exactly. And, you don't want to be that person with the calculator out at the table either. But yeah, ratios are kind of behind the scenes there, helping you be fair.
Okay, so the book starts out with some pretty basic comparisons, I think, to sort of lay the groundwork.
Yeah, super basic. Like, we're just comparing numbers at first.
So we've got Avni and Sherry collecting flowers, 30 for Avni, 45 for Sherry. Pretty straightforward, right?
Yeah, you can tell just by looking at it, Sherry's got 15 more flowers.
Oh, yeah. Okay.
But it's when they bring up this example about the ant and the grasshopper that things start to get interesting.
Okay. Why is that a curveball?
Well, they ask you how much longer the grasshopper is than the ant.
Right.
And you'd think, okay, well, you just measure the grasshopper, measure the ant, and subtract it.
Yeah.
But it's kind of like saying a basketball hoop is 7 feet taller than me,
Okay.
which is technically true, but it doesn't really give you the full picture.
Yeah, it doesn't really fully illustrate the difference between you and a basketball hoop.
Exactly. It's like, yeah, no kidding, it's way taller than you are.
Right.
The difference in their lengths, it doesn't tell the whole story.
So we want to understand not just the difference in their length, but how their sizes compare proportionally.
Exactly. And that's what ratios help us do.
Okay, I'm with you.
Because, I mean, think about it. An ant is just a few millimeters long.
Tiny.
A grasshopper, we're talking centimeters. So it could be 20 times longer, 30 times longer.
Oh, wow. Okay.
So it's not just about the difference in length, but that relative difference.
Right. So instead of subtracting to find the difference here, we want to use division to understand the relationship between those two sizes.
Exactly. Division is the key here, and it's the key to understanding ratios.
Okay, so that's where ratios come in. They help us make sense of these relative comparisons.
Exactly. They reveal those sometimes hidden relationships between quantities.
So I guess a good way to think about it is ratios show us how many times bigger or smaller one thing is compared to another.
And that's a much more meaningful comparison in a lot of cases.
Okay, so the textbook actually gives us a pretty straightforward definition of ratios. They say it's a comparison of two quantities by division.
By division.
And they use that handy little colon symbol
Yes.
to represent it.
The colon, it's a powerful little symbol.
It's like the unsung hero of mathematical relationships.
That's a good way to put it.
I like that.
Because it's not just a colon, it's telling you something's being divided.
Okay, so to put this into perspective, let's go back to the father and daughter example from earlier in the textbook.
Okay, the weights. Yeah.
Instead of focusing on the difference in their weights, which might be significant,
For sure.
the ratio tells us that the father's weight is 3 times that of his daughter, represented as a 3.1 ratio.
3 to 1, boom, right there.
Okay, so we've moved beyond simple comparisons and discovered the power of ratios, these elegant expressions of how quantities relate to each other.
Elegant. I like that.
Yeah, it's kind of elegant.
It's a very concise way of expressing a lot of information.
It is.
But let's not get stuck in the textbook world for too long. How about some real-world ratio action?
Oh, yeah, let's bring it to life. Okay, so real-world ratio action. You got it.
So think about something like making a recipe. Have you ever doubled a recipe or halved it?
Yeah, for sure. Who hasn't? I mean, especially if you're trying to either make a lot more or a lot less.
Right, you're using ratios without even realizing it.
Oh, that's a good point.
Because you have to maintain those proportions to make sure that it turns out right.
Right, or else you're going to have like a cake that doesn't rise or something.
Yeah, you're going to have way too much salt or something.
Right.
Yeah, it's not going to be good.
And it reminds me of something I was reading in the textbook about the golden ratio.
Oh, yeah.
This magical number, approximately 1.618.
Yeah, it's like this mysterious number that pops up everywhere.
I know, right? It's everywhere you look in architecture, nature.
Yeah, it's weird.
It's like this hidden code or something.
It really is like the universe is trying to tell us something.
Yeah, that's a good way to put it.
It's like pay attention to this ratio.
So we've covered ratios, but what about proportions?
Okay, so yeah, proportions.
How do they fit into all of this?
Proportions are all about dividing things up fairly based on a certain ratio.
Okay, so give me an example.
Okay, so like in the textbook, they had the example of Ravi and Ronnie who decide to start a business together.
Okay.
And they both invest money in it, but they don't necessarily invest the same amount of money.
Right. So when it's time to split the profits, you wouldn't just split it down the middle.
Exactly. You would split it according to the ratio of how much they put in.
Okay. That makes sense.
So, for example, if Ronnie invested 3 times as much as Ravi,
Right.
then to divide the profits fairly, she would get 3 times what Ravi gets.
Okay.
It's all about keeping things balanced and fair.
So it's all about maintaining that balance, that fairness based on the initial ratio.
That's a good way to put it, yeah.
And I feel like we see that in so many areas of life, not just business partnerships.
Oh, absolutely. Like splitting a restaurant bill with your friends.
Yes, good example.
If you just split it evenly, you're essentially using a 1.1 ratio, even if someone had an extra appetizer or a bunch of drinks.
Right, and that's fine if everyone's cool with it.
Totally.
But if you want to be really precise, you might factor in those extras and adjust the ratios accordingly.
You can get as detailed as you want.
So we've got these ratios, these elegant comparisons of quantities. We've got proportions, making sure those ratios are applied fairly. But how do we know if 2 ratios are actually proportional?
Good question.
Is there like a secret formula?
Not really a secret formula, but there are ways to figure that out.
Okay.
And the textbook gives us a couple of ways to check if ratios are equivalent.
So like that example with Raj and Anu buying pens.
Oh, yeah, the pens.
What was it about those pens again?
Okay, so like let's say Raj buys 3 pens
Mm-hmm.
and Anu buys 10 pens.
Okay.
So the ratio of how many pens they bought is 3 to 10, right?
Okay. I'm following you.
But if they both bought the pen at the same price per pen, then the ratio of the total amount of money that each of them spent would also simplify down to that 3 to 10 ratio.
So even though they bought different amounts of pens, the underlying ratio is the same because the price per pen was consistent.
Exactly.
Okay, that makes sense.
And that's one way to check if 2 ratios are proportional. They simplify down to the same basic ratio.
Okay.
The textbook also mentions the importance of units when you're comparing ratios.
Right, because you can't compare a ratio of centimeters to meters or something like that.
Exactly. You need to have a common unit to make a meaningful comparison.
Right. You got to compare apples to apples.
Exactly. Like you can't compare how fast a car is going in miles per hour to how fast a cheetah is running in kilometers per hour.
That's a really good point.
You have to convert them to the same units.
Right. Okay.
So units matter.
Units matter.
But once you've got the units squared away, the world of proportions opens up and you can solve all sorts of practical problems.
And speaking of practical problems, let's talk about the unitary method,
Okay, the unitary method.
which the textbook presents as this kind of secret weapon for solving ratio problems.
It's all about simplifying things down to their most basic form.
Okay.
So remember the example with Reshma's notebooks?
Yeah, she was buying notebooks.
Yeah, she buys 2 notebooks for $24. And the unitary method helps us figure out how much just one notebook costs.
Okay, so we divide the total price by the number of notebooks.
Exactly. $24 divided by 2 notebooks equals $12 per notebook.
Okay.
And it's like so simple, but once you know that one unit, you can figure out any number of units.
Right, like if she wanted to buy 5 notebooks.
Exactly.
So just multiply 12 by 5.
Exactly.
Okay.
And the textbook also gives us an example. With a scooter, they can travel 80 kilometers on 2 liters of petrol.
Oh, yeah, I remember that one.
So using the unitary method, we could figure out how much petrol it needs to travel any distance.
Right. You can figure out the petrol needed for 100 kilometers or any distance.
Exactly.
It's a pretty handy tool for sure.
Yeah.
It's really amazing how something like division can be so powerful.
I know it's like this simple little operation, but it unlocks so much.
Yeah, we're not just stuck doing math for math's sake anymore. Like we're actually solving real problems.
Exactly. Like ratios and proportions. They're not just abstract concepts. They're tools.
Totally.
They help us make sense of the world around us.
It's like we've got these new glasses and we can suddenly see ratios everywhere.
You know, it's true. Once you start seeing them, you can't stop.
I know.
Like they're everywhere.
They're in everything.
They're in the balance of a good photograph. They're the ingredients of your favorite pizza.
Speaking of pizza, have you ever noticed how those personal pizzas never seem quite as satisfying?
It's like a big one that you share.
Yeah, even if like the math works out,
Yeah.
like you're getting the same amount of pizza.
I think there's something to be said for the ratio of pizza to shared experience. Like, it's more fun to share.
It's like a social thing.
Yeah.
But getting back to the textbook,
Okay.
there was that part about proportions in the human body.
Oh, yeah. The human body is full of ratios.
It's true. They were saying that artists use ratios to create like realistic and aesthetically pleasing drawings and paintings and stuff.
Yeah, like there's a reason why certain proportions just look right to us.
Like if you see a portrait and something's off with the proportions, it just looks weird.
It's going to look strange.
Yeah.
Yeah.
But when the proportions are harmonious, it's like,
It's pleasing.
yeah, it's very appealing.
It's like our brains are hardwired to appreciate those ratios.
Wow. It's incredible how math is connected to art like that.
It really is.
Okay, so I think we've journeyed from simple comparisons to the profound implications of ratios and proportions.
I think so. We've covered a lot of ground.
We have, but before we wrap up,
Okay.
I had one final thought.
Yeah, what's up?
Remember that example from the textbook about how far a motorbike could go on a certain amount of fuel?
Yeah, I like that one.
Me too. It was a good example of how you can use ratios in everyday life.
Yeah, you can figure out if you have enough gas to get where you need to go.
Exactly, or like how much gas you need to buy for a trip.
Exactly.
Or if you're at the store and you're trying to figure out like what the best deal is.
Oh, yeah. Comparing prices, that's ratios all the way.
Exactly.
Like, is the bigger box of cereal really a better value?
Right.
Got to do the math.
Okay, so to sum it all up, ratios and proportions, they're not just some abstract math concept. They're tools we can use to understand the world around us
I totally agree.
and make better decisions in our lives.
I'm on board with that.
So next time you're faced with a problem, don't be afraid to embrace those colons and fractions. They might just hold the key to the solution.
That's right. Math is your friend.
Math is our friend.
That's not the enemy.
And on that note,
Yes.
we'll say goodbye for today, but keep those ratio brains engaged, and we'll see you on the next deep dive.
See you later.